So in this lesson, what we're going to look at is how elements can be used to make compounds, and we're also going to look at how compounds can be turned back into elements. Now, a recap from previous lesson, elements were the simplest chemicals on Earth, and every single element that we know is found on the periodic table. What makes an element is that it only contains one type of atom. So these three pictures all represent elements. We see helium on the left, and the helium atom is the blue circle, and you can see that box only contains blue circles, so that is an element. The one in the middle, oxygen. Now oxygen doesn't exist as one circle on its own, it exists as two circles. And you can see that those two circles are exactly the same. They're both red, they're the same size, they're the same type of atom. And that whole box is only containing those red circles, those oxygen atoms. So that makes oxygen an element. And the final picture we have is carbon. And you can see there that that picture, every single atom in it is the same. It's the same size, it's the same color. So that makes it an element. Now, every single box is different, but each box only contains one type of atom, and that is what makes them elements. Now, compounds are what we call a chemical that's made from two elements that have reacted together. And the specific definition is that a compound contains more than one type of atom chemically joined together. The important words in that are more than one type of atom, and you need to say that they are chemically joined together. And that means a chemical reaction has happened. And we'll look at chemical reactions in another lesson. We need to know that a compound is made through a chemical reaction of elements, and a compound contains more than one type of atom chemically joined together. So here's an example, carbon reacting with oxygen to form carbon dioxide. So you can see that the compound at the right, in that box, we have a mixture of atoms of carbon, the grey ones, and we have atoms of oxygen, the red ones. So because we've got two types of atom, two is more than one, so that makes it a compound. And you can see also how we've represented that happening. We've put a plus sign between the two elements and then an arrow, and an arrow shows that a chemical reaction has happened, and then we have got our product, carbon dioxide. So those are elements and carbon dioxide is a compound. Now if you're in class, you may get an opportunity to do this experiment, burning magnesium in oxygen or in air. If not, here is a video. You can either look up burning magnesium in oxygen on YouTube, or if you type that link in, it will show you a video of what happens. And just watch it, or if you're in class, get the opportunity to do the experiment and see what happens. Now, if you do see what's happening, you should see that magnesium is a silver metal and oxygen is a colourless gas. Oxygen is all around us. Whenever they burn, we see a bright white light which shows us that a chemical reaction is happening, and then what we see at the end is a white solid powder. Sometimes you'll see it as smoke, but if you give it time, it will settle down to the bottom of your reaction vessel, your reaction flask, and you will see white solid. Now that is a chemical reaction happening. So what we have is magnesium reacting with oxygen to form magnesium oxide. So you can see magnesium oxide on the right hand side contains two types of atom. It contains the magnesium atoms, the grey ones, and it contains the red atoms, the oxygen ones. So it contains more than one type of atom, so it is a compound. So on this one, So another example, so we have got iron, an element. There's only one type of atom in that box, the brown ones. Then in the middle, we've got sulfur. Now sulfur, the yellow atoms, and that box only contains yellow atoms, so it's an element. And then when they react together, you see iron sulfide, and that is a compound, because you can see it contains more than one type of atom chemically joined. A quiz, we've got 6 boxes. Some of these are elements, some of these are compounds, and maybe some of them are neither. So what I'd like you to do first is look for which ones you think are elements. So which boxes do you think are elements? If you need some time to do this, you can pause the video. So if you've paused the video and you've come back, the 3 ones that are elements, because there are 3, are A, B, and D. Now what I'd like you to do from the remaining 3 is identify which ones are compounds. So remember, a compound contains more than one type of element, more than one type of atom chemically joined together. So if you've had time to think, the compounds are C and F. E, we have the pink circles are not joined on to anything, so they haven't chemically reacted. So E is neither an element or a compound. It's what we would call a mixture, and we'll look at mixtures later on as well. Now we're going to look at if we have a compound and we want to turn it back into an element, what do we do? Well, because the atoms in compounds are chemically joined, we need to use lots of energy to break apart those atoms. And how we do this is we use electricity. And we use a process called electrolysis. So the lysis part at the end, that just means breaking, and the electro means electricity. So breaking apart chemicals is electrolysis. Now, if you are in class, you'll get to have a go at doing this experiment. But as I know some of you are going to be at home watching this video, we're going to discuss it. Now, to do the experiment, what we do is we have a solution in the diagram. So in that beaker, we have a blue solution, and it contains a compound, copper chloride. What we do is we attach a power pack that provides electricity, and we have 2 wires coming out of that power pack, and at the end of those wires are 2 rods, and those rods conduct electricity. And we put those 2 rods into the solution and we turn the power pack on, and that means that electricity is going to flow through that solution, and we should see the compound start to fall apart. So what happens is that over time, we see on one of the rods, we get loads of bubbles. On the other rod, we get to see it turn a rusty color, so a brownish orangey metal color. And what that is copper. So the bubbles of gas are chlorine. The metal forming on the other rod is copper. So what we've done is we have turned copper chloride back into chlorine and copper. So you have electrolyzed or split the copper chloride into the elements copper and chlorine. So that process, electrolysis, is needed in order to provide enough energy to break a compound into elements. And when we do this, we use 2 rods, one element forms on one rod and the other element forms on the other. So in this case, we got bubbles of chlorine gas on one, and on the other, we got copper metal forming. So that is the material we've covered. We looked at what a compound is, and that a compound is formed from more than one type of atom chemically joined together. We looked at how we can split a compound back into elements, and to do that we need to use electricity to provide enough energy for that. The rest of these slides are sets of questions for you to practice. Now, as before, if you want time to write down your answers or work anything out, pause the video and then play it again and you'll get the answer. So the first question is a revision question, and choose the right word or words. Elements are the simplest or the most complicated chemicals on Earth. Which one of those words is correct? Well, elements are the simplest chemicals on Earth. Each element is made up of its own kind or its own type of what? Each element is made up of its own kind or its own type of what? Well, that missing word is atom. Each element contains its own type or its own kind of atom. Now, it's a true or false question. Elements contain atoms from other elements. That might seem like a strange question. Do elements contain atoms from other elements? True or false? Well, that is false, because an element only contains one type of atom, and that is the type of atom for that element. So now we've got what kind or what type of atom does carbon contain? So what kind or what type of atom does carbon contain? So that is carbon atoms. So carbon only contains carbon atoms. Now what we're looking for is the definition of a compound. And remember, there were some key words. What is the definition of a compound? So as I said, if you want time to write this down, pause the video. Or if you have it in your head, then we'll see now whether or not you have got it right. Now, a compound is made of more than one type of atom chemically joined together. Now, here's a question for you. Sodium chloride is a compound. What two types of atom do you think make up sodium chloride? What two types of atom? So the answer to this one, it's sodium and chlorine. Now what you find in the names of compounds is that the second part of the name usually ends in IDE, and that changes the name of the element. So what you're looking for in a question like this is the start of the second part of the name. You're looking for that on the periodic table. And chloride, the only element that's close to that is chlorine. Sodium and chlorine. Now we've got a set of questions which are these elements or compounds? So this is a diagram. Is this an element or a compound? If you're writing things down, you could make it quicker for yourself by writing the letter E for element or C for compound. So that one, that is an element. It contains only one type of atom, that blue atom. What about this one? Is that an element or a compound? That one is a compound because we've got two types of atom chemically joined, the reddy orange one and the yellow one. What about this one? Is that an element or a compound? Well, this one is a compound because we've got the orange and the blue atom, two different types, chemically joined together. What about this one? Element or compound? So that one is an element because we've only got one type of atom, the blue one. Right, pick the right word this time. When elements become chemically joined to make a compound, they are easy or difficult to separate. are the elements in a compound, the atoms, easy or difficult to separate? They are difficult to separate. So here we've got an experiment, and I want you to see if you can remember the name of this experiment. What type of experiment is this? So it's a power supply attached to a solution of a compound. What is this experiment called? So that experiment, it's a long and a new word. It is electrolysis. Now, in this experiment, what are we using to split the compound apart back into elements? What are we using? So we are using electricity. That's why it's called electrolysis, because it uses electricity. And the electricity is coming from the power supply. Now, what is the purpose of this experiment? Why do we put electricity across a compound? What are we trying to do? What is the purpose of an electrolysis experiment? Well, the point of this experiment is to split a compound back into its elements. And we've got a final question here. If this is a copper chloride solution, what are we going to form at the two electrodes? So the two rods are called electrodes. What are we going to form on each electrode? So it's copper chloride. And what we form are copper on one electrode and chlorine on the other, because that's how we split it. Copper chloride splits into copper and chlorine. So hopefully you had a go at those questions and you found them straightforward. If you had any difficulty, you can re-watch the video or you can just retry the questions. Also remember that your summary notes have a lot of detail as well on this process for making and breaking compounds. And also we'll have homework to practice these questions with as well. So thank you for your attention this week, and I'll see you next time.